what I want to do is take a couple minutes to go through and explain the binomial theorem and how do we understand and apply Pascal's triangle to use this. So that's what we're going to do today. So let's go to the next slide here. That's the key standard. Let you see that real quick. That's what we're focusing on today. Now, you're used to multiplying binomials. And when you multiply them, as you remember, you use a distributive property. Go to the x, the first x, here the first term. You multiply it by the first term of the second binomial, x times x. You take the first term and you multiply it by the second term of the second binomial, x times 3, and so forth. And you go through and you get a trinomial. That's expanding it out. You're expanding this out. Some students learn it as distributive property. Some students learn it as FOIL. Okay? So the key is to make sure that you understand how to do the basics distributive. Well, how do we square it? Well, all we do is similar to the bell ringer. We multiply the same number by the same number, and we get the perfect square trinomial here. A perfect square trinomial, which was a polynomial identity that we learned. X plus 2 all squared gives us x squared plus 4x plus 4 with the same steps that we did previously. Now, this is where it gets a little more difficult. So if I did this and worked through it, what you would have to do as right now is to do a more lengthy process. So I want you to look here. What you would have to do here is you would have to multiply two of the terms together. I took these two terms first, which was a perfect square trinomial. And then I had to do distribution again. X to the x squared, x to the 4x, x to the 4. I'd have to do this whole thing out, and I would eventually obtain a polynomial. This happens to be a third degree polynomial because it has 4 terms. So, but is there an easier way to do it? Let's see. So let's take a look. Because when you start doing these, you can imagine that's a lot of multiplying, a lot of distribution, and a high potential of making mistakes, which I prefer you not to. So, we have this binomial theorem, and I know many of you are seeing this binomial theorem now, and you're expressing that that is a lot of numbers and equations and very difficult to understand. I'm going to explain it to you, work it through an example, and then show you a shortcut of how to work through this. So the binomial theorem, or expansion, as it says, is a quicker approach to expand binomials, rather than multiplying them all out when we raise to a certain power. So for some of you that want to know what these terms mean, I will help you a little bit. This is called the summation. This is the Greek letter summation here. You see the sum, and it starts at 0 and it goes to the power n power. This is what we call a combination notation, n factorial. And remember, a factorial on your calculator, like the factorial 3 is 3 times 2 times 1. The factorial 4 is 4 times 3 times 2 times 1. All you do is go down each number, multiply. That's what the factorial is. So, but that's not our important part here. What I want to do is, let's see what an example looks like. So if I had to do it this way, what I would have to do is, here's my highest exponent, 3. So n equals 3. You always start off with 0. You first take the 3 factorial, that's the n. It stays constant through the whole thing. And this right here is the highest number minus k. Highest number by the next k. Highest number by the next k. Highest number by the next k. And all k is doing is counting up from 0 to 3. And look at your exponents. They are changing. 3 minus 0, 3 minus 1, 3 minus 2, 3 minus 3. And these are increasing. 0, 1, 2, 3. So, let me see here. Let me clear those. Let me stop annotating. Let me go to the next slide. But What I'm going to tell you now is there's an easier way of doing this. An easier way of doing this that we're going to go through it. So I want to show without direct multiplication. And what I want to do is teach you what's known as Pascal's triangle. Because Pascal's triangle is what we're going to learn. So as I work through this example, let me clear these drawings. This is what's known as Pascal's triangle. So when you form Pascal's triangle, it's not that difficult once you see the pattern. You can see the 1 stays on the outside, 1 and 1. Well, 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 4 plus 1 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. So this is what we're doing. We're learning Pascal's triangle, and we're going to see how to use this. So let's take a look and see if we can see the application. And we'll start with this example here. X plus y equals 3. X plus y is equal to 3. So let's first start off with Pascal's numbers. I'm going to write them right up here for you so you can see. Remember, we had 1. We had 1, 1. We had 1. 1 plus 1 is 2, 1. 1. 1 plus 2 is 3. 2 plus 1 is 3, 1, 1, 4, 6, 4, 1. And it goes on. 5, 10, 10, 5, and 1. And this goes on. So when you do these problems, like I said, I'm going to walk through this with you, but you can look at the slides and go back through them. So just listen as I kind of walk through it with you of how we do these. The first thing we do is we have to determine Pascal's numbers. We have to determine Pascal's term. Since this is a 3, you're going to have 4 that you're writing, always 1 plus that number. Now, you look at this row right here, 1, 2, 3, 4, 5. So whatever this exponent is here, that matches the row with that number in there. So you see the 3's here. So this is the row I'm using. If that exponent would have been a 4, this would have been the row. If that exponent would have been a 5, this would have been a row, and so forth. So I first put Pascal's numbers. Here's 1. Here's 3. Here's 3. And here's 1. Okay. Now, what I want to do next is I want to now put the first term. And I'm going to call this term 1. First term. So here's my first term, my first term, my first term, and my first term. That's x. So I just put x, 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 and x. And if that would have been a negative x, I would have put negative. If that would have been a 5x, I would have put 5x. Whatever that first term is, you put the same number. And you start with this highest exponent is 3. So I count down. 3, 2, 1, and 0. Now, I need to go with the second term. This is term 2. So term 2, term 2, term 2, term 2. And you will get faster with this and it'll become easier. So then I put the y, 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 and y. And now I go backwards with the exponents. 0, 1, 2, 3. And if it helps you, 3 plus 0 is 3. 2 plus 1 is 3. 1 plus 2 is 3. 0 plus 3 is 3. And that's how I add them and make sure I do it correctly. So now let's see what I obtain. So I have a plus between these. These are all different terms. Well, anything to the 0 power is 1. So this becomes simply x cubed. So all I do, I apologize, my dog must have heard something. So y to the 0 is 1. So 1 times x cubed is simply x cubed. Y to the first is y, 3y. So this is plus 3x squared y. 3xy squared, so plus 3x y squared. X to the 0 is 1. I'm left with y cubed. Y cubed. So my final answer, x cubed plus 3xy squared. Sorry. Let's erase that. I put it in the wrong place here. 3x squared y plus 3xy squared plus y cubed. So this is when I ask for things to be expanded. That's what I'm looking for you to do to expand it, and we're going to work this way. So what I'm going to show you now, we'll clear these drawings, and I'm going to stop annotating for a minute, and I'm going to get out of this screen here. Let's go to right here. Now, on this one, on a scratch sheet of paper, I want you to work with me as I go through it. And I'm going to work through this and see if you follow my steps. So the first thing we want to do is kind of make sure we understand Pascal's triangle. So you can write this once and keep it beside you, or you can memorize it and write it each time. I recommend you kind of just kind of write it once and kind of keep it next to you. It's probably be easier than trying to write it each time. So 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Okay, so I've written them down. So let's take an idea. Let's start off with, like I said, let's start off with Pascal's numbers. So this is 3, so I'm going to write it 4 times. There's my first. There's my second. There's my third. And there's my fourth. Remember, this is Pascal's number. Pascal's number. Pascal's number. Pascal's number. I'll give you about 5 seconds here. Make sure you know which ones to choose. So this was 3. So here's my 3. So I'm going to choose the 1, the 3, the 3, and the 1. If that's what you thought, you were correct. If that's what you thought, you were correct. So the next step, I'm going to look at the first term. So term 1. And I'm going to draw my parentheses because it helps me stay organized. You can also do this vertically. I'm doing it horizontally, but you can also put them underneath if you prefer to do vertically. So I put my first term in here, x, 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 and x. And then all I do is I look at my exponents. There's my exponent 3. So I go 3, 2, 1, 0. I will catch my breath real quickly here, and let's make sure we're ready for the next step. As you remember, now we want to look at term 2. So I draw my parentheses. I draw my parentheses. And I do the parentheses, they help me stay organized. You may not do it. So let's take a look here. So my second term is 2, 2, 2, and 2. Now look at my exponents. It's 3, but I'm going to go backwards this time. 0, 1, 2, and 3. I'm going to, let's see here, I'm going to add my plus, plus, plus. Someone say, well, when is it negative? Well, I would just put the number in here. Like, for example, if this was negative x, put the negative in here, and it'll work out to be minus on some of them. If this was negative 2, put the minus in there. Sometimes the number will be subtraction, but it's easier right now just to put positive. So let's see what I get. 2 to the 0 is 1. 1 times 1 is 1. So this is just simply x cubed. 2 to the first is 2. 2 times 3 is 6. So that's plus 6x squared. 2 squared is 4. 4 times 3 is 12. So that's plus 12x. 2 to the cubed is 8. Anything to the 0 is 1 times 1. So plus 8. So that's how we're doing these. And as we practice, we'll get improving. But I wanted to spend a little bit more time today to go through there. So that's how we do the binomial theorem. And we use Pascal's triangle to help determine the coefficient.